Hi guys, welcome back to AP Environmental Science. In today's video, we're going to be discussing the greenhouse effect and increases in the greenhouse effect and how that can lead to global change. You might notice that the last part in your notes, which is 2.13, the global change, there is no notes for those per se. There are some notes in the slide, but it's not really something that we're going to go over right now. We just have to know the basics of what climate change is, and then later on throughout the rest of the units, we'll embed what we know of what we're learning, and we'll embed it into climate change. Okay. So for now, what we're embedding into climate change is the greenhouse effect and increases in the greenhouse effect. So, what is global change? Global change includes global climate change and global warming. As a reminder, climate is the average precipitation and temperature in an area. Climate depends on a few different things. It depends on geography, wind patterns, ocean currents, spin of the earth, solar insolation, all of that stuff. So we should know that closer to the equator, we have warmer, wetter climates if you're in South America, and warmer, drier climates if you're in Africa. And then the poles tend to be a lot colder. And global change is when those different parts of the globe that have a pretty standard average temperature and precipitation begin to change over time. So, global change is a change that occurs in the chemical, biological, and physical properties of the planet. Some types of global change are natural and have been occurring for millions of years. What is different is the rate of change for many global change issues, and the causes that can be traced back to human activities. So, global climate change refers to changes in the average weather that occurs in an area over a period of years or decades. So, how does this kind of start or begin? There's a few factors that contribute to this, and they all kind of impact one another. The very first thing is just the general warming of the planet. And you have increased temperatures all around the globe, or increased temperatures more intensely in certain parts of the globe. And those are contributed to by a few different things. So, first, we have just basic global change, which is when you have rising sea levels, the increased extraction of fossil fuels, which are non renewable resources like oil and coal. We have increased contamination of the environment via pollution, altered biogeochemical cycles. We'll talk about these next unit. And really, the rest of this stuff is all of the different topics that we go into further down this course. And that's why we really talk about climate change embedded within each unit rather than all at once. That way you can get it as we go over the course. So, what is the greenhouse effect? Oops. There we go. What is the greenhouse effect? For those of you who are watching this after we do our lab, all of you by this point should have done the greenhouse effect gizmo, where you explored how increasing the rate of the greenhouse gases in the atmosphere contributes to a warming of the atmosphere. Well, why is that occurring? What is happening? We should know by now that the sun produces light, energy, which is warm, and it comes to Earth and it hits us, and some of that sunlight is reflected back into space. Objects with high albedo have a high reflection of light, meaning that the majority of the light that hits it is reflected back out, meaning that the heat is going to leave the atmosphere. Objects with a low albedo have a low reflection of light and are instead going to be absorbed. However, when you have the greenhouse gases leaving the ground and entering the troposphere and the stratosphere and other layers of the atmosphere, it actually prevents the UV rays from leaving the atmosphere and instead get re-radiated or bounced back or reflected back into Earth. So the energy from the sun strikes Earth, and some radiation is emitted back towards the atmosphere. The greenhouse effect is the absorption of infrared radiation by atmospheric gases and re-radiation of the energy back towards Earth. With addition of more greenhouse gases, this normal process is exacerbated. So here's what I just talked about Incoming solar radiation consists primarily of UV and visible light. It comes in, goes to the atmosphere, gets absorbed by different kinds of surfaces depending on their albedo, and also reflected. About 1/3 of the solar radiation is reflected from the atmosphere, clouds, and the surface of the planet back into space. The remaining solar radiation is absorbed by clouds and the surface of the planet, both becoming warmer and emit infrared radiation. Much of the emitted infrared radiation from Earth is absorbed by greenhouse gases in the atmosphere, and the remainder is emitted into space. As the greenhouse gases absorb infrared radiation, they warm and emit infrared radiation, with much of it going back towards Earth. So, this then causes warming of the planet because this radiation and this light is warm. So, certain gases absorb more infrared radiation than others. Greenhouse gases only make up a very small amount of the atmosphere. We know that nitrogen and oxygen make up the majority of the atmosphere, and the rest of the gases are trace gases, and some of them are greenhouse gases. Water vapor, carbon dioxide, which is the most abundant greenhouse gas, methane, nitrous oxide, and even the CFCs that we've talked about with stratospheric ozone depletion. So, what are the sources of these different greenhouse gases? CO2 is primarily from the burning or the combustion of fossil fuels, decomposition, and deforestation. Remember that plants perform photosynthesis and they take in CO2. So, plants and all photosynthetic organisms, they are going to breathe in or take in CO2 from the atmosphere, which would reduce our global CO2 rates. However, with mass deforestation, the permanent removal of trees, you're going to have an increase in CO2 levels because now you have less organisms taking in the CO2. And then, of course, the bigger one is the fossil fuel combustion. Methane is natural gas extraction and combustion, as well as from animal culture. So, methane is primarily produced with a bunch of stinky cow farts. We have so many cows on our planet, primarily for sources of meat, so people can live. And when cows fart, they release a ton of methane. Nitrous oxides can be found in agricultural soils. The denitrification of nitrate, especially in overwatered, overfertilized soils. We'll talk about this in our next unit, as well as later down the road when we talk about farming methods. And CFCs, we should know about this by now. This is from refrigerants and aerosol products. Water vapor is technically a greenhouse gas by definition, but it doesn't drive atmospheric temperature change. It's just in the atmosphere. Okay, so the greenhouse warming potential is an estimate of how much a molecule of any compound can contribute to global warming over a period of 100 years relative to one molecule of CO2. So as we go down the list, chlorofluorocarbons are the most potent or have the biggest global warming potential because they stay so long in the atmosphere. And also, don't forget that CFCs contribute to stratospheric ozone depletion, which is going to allow more harmful UV rays to enter the atmosphere because the ozone layer is not blocking them. So, what are some natural, which are non human sources of these greenhouse gases? Volcanic eruptions release carbon dioxide. Decomposition and digestion releases methane and carbon dioxide. Denitrification, which we'll talk about next unit, releases nitrous oxide. Evaporation and evapotranspiration is the release of water through the leaves. Anthropogenic, remember that word, meaning human caused. Burning fossil fuels, agricultural practices, deforestation, landfill use, and industrial production of new chemicals. So, all of the things on the left, these things have been happening for millions of years and will continue for millions of years. And this process has, released small amounts of greenhouse gases. It's these things, the human activities, that have really increased the amount of GHGs that we release into our atmosphere. So if we look at the different types of greenhouse gases, where are they primarily coming from? Methane is primarily coming from natural gas and petroleum. That is a human anthropogenic cause. Nitrous oxide, 74% is coming from agricultural soil management of fertilizers. And then carbon dioxide, the majority of it is coming from transportation. Cars run off of oil, and your cars have huge emissions. Later this year, when we do our air pollution unit, we're actually going to test to see the emissions of various cars on campus. Oh, and that's it. Okay. I thought there was more. For the, ignore those. For this, we're just going to talk about it later throughout each year. For now, you guys can just review the graphs and really just see how the globe has been changing over time in different areas, and it will be embedded throughout the course. If you guys have any questions, please let me know. As a reminder, your test is coming up for this unit. Make sure you guys work on the study guide. Oh, sorry. I will be here after school if you need to check in with me. I will be here. Remember, those FRQ practice questions are super important. Try and at least get those done and run them by me. That way you are prepared for the test. I will see you guys all soon. Bye and have a good day.